Hello children. Today we are going to start with chapter number 5 of your physics books of class 8 and the name of the chapter is Upthrust in Fluids, Archimedes Principle and Flotation. The objectives of the chapter are: in this chapter we will study about definition of upthrust, its properties and reason for upthrust, buoyancy, conditions for a body to float or sink in a liquid, Archimedes principle and its proof, density, relative density and its measurement, flotation and principle of flotation, relation between volume of submerged body and density of the fluid in which that body is submerged, and applications of principle of flotation. Our today's topic is topic number 5.1, buoyancy and upthrust. This topic is given on page number 103 and 104 of your books. The objectives of the topic are: after the discussion of these topics, you will come to know what is upthrust in fluids, what is buoyancy, what are conditions for a body to float or sink in a liquid. So, let us start with our today's topic, that is buoyancy and upthrust. Buoyancy and upthrust can be explained with the help of a very simple example. The example is like that: when we try to push a mug or a cork in a tub of water, we find it difficult to push it in it. We find and we feel an upward force exerted by the liquid on that mug or that piece of cork. Till the time we'll be applying that force on mug, the mug will be inside the water. As soon as the force will be removed, the mug will be released, it will bounce back to the surface of the liquid again. It means there exists some force which actually liquid is exerting on the body. So, with the help of this example, buoyancy and upthrust can be explained. The body rises back, the body bounces back when we try to push it in the water. So buoyancy is defined as the tendency of a body to rise when it is submerged in a fluid. Fluid is anything which can flow, my dear children. Gases and liquids come in fluids. Then we'll explain upthrust. Buoyancy is a property, it is tendency. Upthrust or buoyant force is defined as the upward force which is exerted on the body by that fluid in which it is submerged. Due to this force, the body bounces up. The example which we have discussed clears that there are some forces which exist on the body, which are exerted on the body, which is submerged in a fluid, which act on a body which is submerged in a fluid. So, the forces which act on a body when the body is submerged in a fluid are: first is weight of the body, which acts vertically downward, as we all know. Second is upthrust exerted by the fluid, and upthrust, as its name suggests, will act vertically upward. The diagram shows the weight of the body acting vertically downward, submerged in a liquid, whether it is completely submerged or it is floating on its surface. And one arrow, red color arrow is there, which shows the upthrust exerted by the liquid on the body. Dear children, let us read the topic discussed today. The name of our topic is buoyancy and upthrust. When a body is partially or wholly immersed in a liquid, an upward force acts on it. This upward force is known as upthrust or buoyant force. It is denoted by the symbol FB. We have discussed about buoyant force just now. So, the upward force exerted on a body by the fluid in which it is submerged is called the upthrust or buoyant force. The property of a liquid to exert an upward force on a body immersed in it is called buoyancy. This property can be demonstrated by the following experiments. Experiment number 1, which we have just now discussed. Take an empty can close its mouth with an airtight stopper, put it in a tub filled with water. It floats with a large portion of it above the surface of water and only a small portion of it below the surface of water. If we push the can into water, we feel an upward force which opposes the push, and we find it difficult to push the can further into water. It is also noticed that as the can is pushed more and more into water, more and more force is needed to push the can further into water till it is completely immersed. When the can is fully inside the water, a constant force is still needed to keep it stationary in that position. It is the maximum upthrust on the can. Now, if the can is released at this position, it is noticed that the can bounces back to the surface and starts floating. We have already discussed this experiment, children. In this, the can bounces back, it rises up due to upthrust exerted on it by the liquid. Now, there is an important note. Like liquids, gases also have the property of buoyancy, that is, a body immersed or placed in a gas also experiences an upthrust. All objects, including ourselves, are also acted upon by a buoyant force due to air. But we do not feel it because it is negligibly small as compared to our own weight. On the other hand, a balloon filled with hydrogen or any gas less denser than air rises up because the upthrust or buoyant force on balloon due to surrounding air is more than the weight of balloon filled with gas. Now, we will discuss the conditions for a body to float or sink in a fluid. This is the diagram of a body in a liquid. W is the weight of the body acting vertically downward, and F-B is the maximum upthrust acting upward. In this case, we can say that there are two forces which act on a body when it is submerged in a liquid. The first force is weight of the body acting vertically downward, and the second force is upthrust exerted by the liquid on the body. Now, my dear children, if the weight of the body will be more than the upthrust, that means if this downward force is greater than this upward force, the body will sink in the liquid. And if this upward force is greater than this downward force, the body will not sink in the liquid, it will float. And in case these two forces are equal, W is equal to FB, the body will float like this, the way it is floating in this diagram, completely submerged in liquid. When FB will be greater than W, the body will float partially immersed in the liquid. Let us read the topic for better understanding. When a body is immersed in a fluid, two forces act on the body. The weight W of body, which acts vertically downward, and the upthrust FB, which acts vertically upwards. We have noticed that the upthrust depends on the submerged portion of the body. It increases as the submerged portion of body inside the fluid increases and becomes maximum when the body is completely immersed inside the fluid. This figure shows a body held completely immersed in fluid with two forces W and F-B acting on it. In this situation, F-B is equal to W. Depending upon the density of the fluid, the maximum buoyant force F-B can be greater than, equal to, or less than the weight W of the given body. Whether the body will float or sink in a fluid depends upon the relative magnitudes of forces W and F-B. Now, two different cases are, if upthrust is greater than weight, F-B is greater than W, or F-B is equal to W, the body will float, it will not sink. If F dash B is greater than W, as I told you, the body will float partially immersed with only that much part of it inside the liquid. And if the upthrust FB due to which becomes equal to weight W of the body. But if F dash B is equal to W, the body will float with the whole of it just immersed inside the liquid. Thus, for a floating body, net force acting downwards is 0. If F dash B is less than W, the body will sink due to the net force W minus F dash B acting on the body downwards. If M is the mass of the body, it will go down into the liquid with an acceleration A, such that MA is equal to W minus F dash B, or A is equal to W minus F dash B by M. Here we have ignored the viscous force of the liquid. Unit of upthrust. The upthrust, being a force, is measured in Newton or kgf. This was the reading of the topic. Now let us see a video for better understanding of upthrust.
If you try to lift a weight from a swimming pool and then try to lift the same weight from the edge of the pool, you will notice that it feels heavier when it is out of the water. This was supposed to have been first explained by the Greek scientist Archimedes. He said that the water exerts an upward force or upthrust on any object in it. When you weigh an object in the air and then in water, the difference between the two readings show the upthrust, which is often called the loss in weight of the object. All liquids and gases are known as fluids. A fluid exerts an upward force when an object is immersed in it partially or wholly. This property is called upthrust or buoyancy. It is denoted by FB. Upthrust can be greater than, equal to, or less than the weight W of the body. This upthrust determines whether the body floats or sinks in a fluid. If FB is greater than W or FB is equal to W, then the body will float. But if FB is less than W, then the body will sink. Upthrust, being a force, is measured in Newton, N. Lifting a bucket of water from a well, pulling a fish out of water, and a body weighing less in the air than in vacuum are examples of the effects of upthrust.
So, this was the topic of discussion for today. Now the question answers to be planned. Please plan question number 1 till 7 of page number 109 of your books. Read and revise the chapter once. Thank you so much.